was really in preparation for the book Data in the Collection at the Museum of Modern Art. And this 2008 publication, as Anne mentioned, is devoted exclusively to scholarship based on close examination of approximately 70 objects from MoMA's unrivaled data collection. The initial research for each of the object-based essays began with an in-depth technical examination, which prompted some of the initial questions about the Crotti drawing in MoMA's collection. At that time, we traveled to Philadelphia to see the drawing in that collection, and not being able to have the objects in the same room, we sort of left with the opinion that the drawings appeared to be executed on similar papers, but really that just sort of prompted further questions. So the first thing I'll do is talk a little bit in depth about the MoMA drawing, some of its specific physical characteristics. The paper is 21 5/8 inches by 13 13/16 inches, or approximately 55 by 34.5 centimeters. And I think the fact that the centimeter measurements are more manageable probably says something about where the paper was made, although I have no proof of that. The top, bottom, and left edges have the original decals, and you'll notice that I have decals in quotations because while the sheet does retain 3 irregular edges that mimic the decal edges of handmade paper, the edges on this paper don't result from the same paper making process, and Scott's going to talk a little bit more about that. The right edge of the drawing is torn, and then in transmitted light you'll see that the paper has a very even formation. And what we mean when we say that paper has even formation is we mean that the uniformity of the distribution of the paper fibers throughout the paper is very even. And there's no watermark, which might provide some information about a paper maker or the place of manufacture. So Scott is going to talk now a little bit about the Philadelphia drawing.
Okay. If I can avoid a coughing fit here, I have a cold, so I have a hard time not coughing. Thanks, Scott. Okay. Okay, so now I will describe the paper support of the PMA. Excuse me.
Can we do it?
I apologize. I think I can do it. Okay. So the PMA drawing support. It's a wove paper with a moderate surface texture. The paper sheet measures approximately 21 by 13 5/8 inches. However, on close inspection, we see that the top, bottom, and left edges have all been trimmed. The right edge appears to have been carefully torn either along a straight edge or a folded crease. And in transmitted light here, we see, as Scott had mentioned with the MoMA work, the sheet formation is relatively uniform. There's no watermark or embossed stamp from the paper manufacturer present. There are a number of repairs visible, including some filled losses and some edge tears that have been reinforced on the recto and verso with Japanese paper and paper pulp. It appears that the trimming of the edges may be related to this, or may have occurred or been related to the time of these repairs, which is unfortunate as it prevents us from knowing the original dimensions and edge characteristics of the sheet. However, what we can see in these details, at the upper left corner, there appears to be a small area of original decal edge up in that corner in the left. And on the right in this detail, we can see also that there are tackles on the corners that show in transmitted light. And these tackles seem to indicate several campaigns of tacking and removing the drawing from a surface. Another examination technique involved using strong raking light. And here we have raking light passing across from the left to bring out the topographical features or the surface texture of the paper. And in fact, when we examine the papers in strong raking light, what we observe are a pattern of very fine diagonal striations in each paper. In details of both drawing supports, we can see that these diagonal grooves or striations are running in this orientation from bottom right to upper left. These textural features are imparted during the paper making process, and I'll speak just a little bit more about that now. Oh, again, in this detail at slightly higher magnification, you can see the texture of the two papers quite clearly. So we can say that both drawings were executed on similar papers. Just to recap the features observed, the relatively uniform sheet formation, the decal edges, and the pattern of fine diagonal grooves. I think the paper thus exhibits characteristics of a wove mold-made paper. As Scott may have mentioned, well, he did mention that when we refer to a wove paper, it means that when the sheet is formed on a very fine screen and we view it in transmitted light, it will lack the very prominent laid and chain wire lines that characterize what we call a laid paper. So the papers are probably made on a cylinder mold machine, which has been used since the 19th century to produce good quality papers that imitate handmade sheets. And here I've chosen just a few images to show the basics of the cylinder mold process for paper making. During the process, a rotating drum covered with a fine wire screen rotates through a vat of dispersed fibers to form sheets. And the surface of the drum can be divided into multiple discrete molds separated with wire frames to form separate individual sheets. And in the upper right of this image, we can see the frame edge on the cylinder, and this image also includes a wire watermark on the screen that would be imparted to the paper sheet that will be formed on it. And just here an image of workers removing paper sheets from the felt conveyor that have been formed on this cylinder machine.
So one of the really sort of quick and dirty examination techniques that we can do as paper conservators is to look at a paper under ultraviolet light to see if the paper fluoresces. Many modern papers contain chemicals called optical brighteners, which are added during the paper making process, and they are added to increase the whiteness of papers through the action of fluorescence. And these chemicals came into widespread usage in the paper-making industry beginning in the 1950s, and they're what is the source of the very super white papers that we have today. So if a paper fluoresces under UV light, as the paper on the right does, then it's pretty much a dead giveaway that the paper was dates no earlier than the 1950s. If there are no optical brighteners, however, like the paper on the left, then no dating information can really be inferred because papers without optical brighteners continue to be made, especially high-grade, artist-grade papers. We neglected to photograph, but did examine both drawings using UV, and neither drawing fluoresced. So unfortunately, that means that we can really draw no conclusions about the dating of the papers based on that. Fluoresce. So we also commissioned a fiber analysis as part of this examination. And the objectives were first to identify the fiber composition, which may provide some clues about the manufacturer, possibly identify components in the paper that may suggest the time period of manufacture, and then also to compare the two papers to establish some level of similarity or dissimilarity. So the way the fiber sample occurred is we first took some fibers from the paper sheets. They were dispersed in water and examined with polarized light microscopy at 100 to 400 times magnification. So that's the image that you're seeing on the right, an example of that. The fibers were also stained with a chemical called graph C stain, which is a stain that helps to identify fiber types, and it provides very general information that helps you to differentiate between pulp types. And in this case, the red stain indicates that the fibers were a non-lignin containing fiber, and that would be something like cotton or a bast fiber like flax or hemp. And as part of this analysis, we also, the fiber lengths were measured, and so the range and proportion of fiber lengths in both pieces of paper was similar, with the majority of fibers on the very short side, which suggests that the paper-making pulp was heavily beaten during the initial processing, and this is this makes a lot of sense for a machine-made paper. The fiber analyses also suggest that both papers contained flax and cotton fibers, that there was no other fiber type like wood or straw present in the samples. And here I'm showing a cotton fiber on the left in the Philadelphia drawing sample, and then the same fiber on the right viewed under polarized light microscopy and showing the very characteristic morphology of a cotton fiber. Also, there were bast fibers in both samples, which would be a linen or flax, and on the left, an example of one of the bast fibers from the Philadelphia Museum sample, and then on the right, that same fiber seen in polarized light, showing the very characteristic cross striations, which identify a bast fiber. So the conclusions from the fiber analysis were that, first of all, the fiber composition is consistent for both papers. Both papers are composed of rag fibers, which is very typical of good quality artist papers. The fiber lengths reveal that they were heavily beaten, which is consistent with machine manufacture. There is no wood pulp or other fiber types were observed. So in sum, the fiber analysis suggests that the two papers are more similar to each other than they are different, but that the fiber composition alone is not helpful in determining if the paper was made in the early or mid-20th century. And the fact that the two papers are very similar, as you'll see, is not a surprising result. So now Scott is going to talk about the drawing media.
Yeah. Okay. Thanks, Scott. So yeah, I'm going to introduce the drawing materials, and then we'll trade off again. So the drawing media Crotti used for both drawings were examined closely, and while the compositions of the works appear nearly identical, each work is distinctly different in execution. The PMA drawing shown in detail on the left is executed in both charcoal and graphite, and the MoMA work shown at right is done entirely in graphite. And Scott, would you like to describe the MoMA work?
Sure. Yeah. We're very proprietary with our drawings. So the MoMA drawing is rendered entirely in graphite pencil. It is rendered very linearly and schematically with very sketchy and tentative lines that really reveal the hand of the artist. There is a faint horizontal line. The composition is sketched upon this grid that is now mostly erased, but it consisted of a vertical line and a horizontal line, which both pass through the center of the sculpture's proper left eye. There are many, many compass holes in both eyes, and the compass was most likely used to draw the iris. The other holes may have resulted from Crotti using a compass to measure out distances from the eye as he plotted specific points within the composition. Dark pencil ticks, distinct from the composition, can be seen at the hairline, at the brow, at the tip of the sculpture's nose, at the lip line, and at the base. There are no compass holes corresponding to the arcs at the bottom that represent the sculpture's base, but they would have likely been off the bottom of the sheet regardless. Crotti used a straight edge to draw the support wire. The smudging of the graphite and the erasures to clean that up probably resulted from the artist as he was rubbing his hand over the paper, laying out the work. So, given all this evidence, one can really imagine Crotti sketching directly from a print of the Julie photograph, carefully measuring out distances and proportions to draw this enlarged image of the sculpture. Just a few more inscriptions. Anne and Jim have spoken about this inscription, which is really the source of a lot of the confusion about the dating of these two drawings. down in the lower right corner on the recto. On the verso, 3 inscriptions. On the upper left, 1/8, which we don't really know what that means, 55 by 34.5, which is the dimensions of the drawing, and hence the reason that I think probably at least made in a place where centimeters were of importance. And then the number 23818, which is probably an inventory number or something like that from the estate.
Okay. Here now a detail of the PMA work. Close inspection of this drawing reveals the use of graphite is somewhat more limited than the MoMA drawing, and that the graphite was apparently used to first lay out or trace the basic elements of the composition. And here are some of these graphite lines visible in the hair and in the forehead. Elsewhere, the graphite was followed by extensive use of charcoal to more fully define the features and to provide additional shading and contrast. This shading is most prominent in the forehead, which you can see. And in addition, when we looked at some of the long flowing lines like those in the jaw line, we see that the charcoal actually flows right over the top of faint graphite lines underneath. So as a result of this fairly extensive use of charcoal, it does become difficult to determine the full extent of the graphite underdrawing, but we can determine that that's the process. Inscriptions. On the inscription of this work, at the lower right, as you saw earlier, we have J. Crotti, 1915. And on the verso, we have, let's see, in the verso, we have Marcel Duchamp in a cursive script, and then at the bottom, we have Rose Fried in sort of a combination of small and uppercase and lowercase block letters. In the upper right, we have an ink stamp present, and this appears to be a French customs export stamp. Yeah. Back to Scott.
All right, so as Anne mentioned, one of the really unique opportunities that this exhibition has afforded is the opportunity to examine the 2 drawings in the same location next to each other. And this type of examination of objects from different collections can be extremely difficult logistically to coordinate. So the opportunity to do that is, I can't stress enough how great that was. And so no matter how detailed the email messages are or the digital images that you take, there's nothing like actually having the 2 objects next to each other, and the discoveries that can be made are really amazing. So in February, a group of curators and conservators met in the Lunder Conservation Center and spent the better part of a day closely examining these 2 drawings and the related photographs and other materials. I'm just showing you some images from that day. And so it became apparent really quite quickly that the 2 papers were indeed very similar and the same. They were very similar to each other. The characteristic surface texture that Scott was showing you before was present on each sheet. Moreover, the torn edges of the drawings, the right edge here on the MoMA drawing and the left edge on the Philadelphia drawing, clearly bore some relationship to each other. And so once we were able to orient the drawings so that the torn edges were aligned, it became pretty obvious that the 2 drawings were in fact taken from the same piece of paper, that it was one single sheet of paper that the 2 drawings were executed on. And in fact, the irregular bits of paper along the torn edges line up so beautifully in some sections that it's as if the edges had not been disrupted since they were first torn. So it's really quite amazing, and no amount of emails, as I said, would accomplish this. So the drawings were executed on a single sheet of paper, measuring approximately 55 by 69 centimeters, or approximately 22 by 28 inches, which was torn down the middle into 2 separate sheets. And so hold on to your seats. This, whatever. XP, it has all these functions. So now Scott's going to talk about our ideas about the order of execution.
All right, thanks, Rob. Great use of the animation. That's okay, so as a result of these discoveries, a proposed order and method of execution can be inferred. First, that the MoMA drawing was done in graphite on one half of the paper sheet, and as Scott discussed, the MoMA drawing was carefully plotted out as indicated by the tick marks and the compass holes. Next, the paper was folded in half, and the PMA drawing carefully traced in graphite over the top of the MoMA drawing. The PMA drawing was then further worked and developed in charcoal, either before or after the sheets were torn to separate the drawings for all of these many years until just last month, in fact. And recapping the physical evidence of this physical process, we have, just going to go back to this. We do have the 2 drawings on the same paper, but importantly, they're on opposite sides of the paper. And I don't know if that came across in the previous slide, but they are done on opposite sides of the sheet. Here we see the MoMA drawing on the left and the verso of the PMA drawing on the right. And that's the way that the sheets match up on the opposite sides of the sheet. And when they're placed face up and overlapping, as in this transmitted light image, you can see that the works were also positioned almost identically on the paper sheet, which is further evidence that they were done while the sheet was folded and then they were torn. And it's great to see the drawings like this because it does appear that they form a single image when we overlap them. Additional evidence for this proposed tracing technique for the PMA drawing was the discovery in the form of an offset or transferred graphite line visible on the reverse of the PMA drawing. And circled here in the forehead area are the sketched out MoMA drawing on the right, and then this very forceful, distinctly drawn graphite line at left on the PMA drawing. And when we examine the reverse of the PMA work, we see that this forcefully drawn line from the front appears to have picked up or transferred the graphite from the MoMA drawing of which it was placed on top of. And again, in these details, you can see the transferred graphite on the reverse and how it exactly corresponds to the line drawn both on the front and the forehead lines on the MoMA drawing. And here under magnification, we see this graphite line. And we see that the line consists of graphite particles that are scattered across the paper sheet, and it lacks any tool mark striations that we would tend to see accompanying a drawn line versus a line that is simply transferred from pressure. So what about other Crotti drawings on the same paper? So far, we've not yet identified or observed any of the same papers, or this same paper elsewhere, but we really haven't had the opportunity to pursue this in earnest. However, recent examination of approximately 16 drawings by Crotti revealed a whole range of papers, a variety of papers from different periods of his career, and so far none have matched the Duchamp portrait paper, not yet anyway. And here in these details in transmitted light, we can see several different papers that Crotti used that we were able to examine. And we see works from as early as 1900 and other works from the 1950s. And again, in this slide, we see 4 other drawings. And some of these are actually dated to the 20s, and we had a few that were dated to the early 20s. But unfortunately, again, none of them matched up with the portrait paper. Unfortunately, this hasn't allowed us to determine the age or the time that the Duchamp portraits were executed, but perhaps we may be fortunate to find one or a similar matching paper in the future, particularly using a reference collection of modern papers like the one at the National Gallery, which we hope to use, or hopefully we'll find another Crotti drawing with a firm dating that will match. So in conclusion, to sum up, we have the 2 drawings that were executed. This is our proposed method of execution based on the technical examination. And we think that certain details, particularly the fact that the drawings were carried out on opposite sides of the sheet and that are exactly positioned on the paper of what was originally a larger sheet, suggest that they were drawn